My name is Johnny Shields. I'm the founder and CTO of a company called TableCheck. We're based in Tokyo, Japan. I flew out from Tokyo. Our company works with restaurants, so we do bookings and guest management. We're in about 9,000 restaurants today and growing. So you probably haven't heard of us in Europe because we're mostly in Asia, but we're coming this way soon. So hopefully in a few years, people here will encounter us. We also work with Cybergizer. So Sergey and his team, we've worked with them for 5 years. They're fantastic engineers. They power all our Ruby and Elixir development. They're really wonderful, and we really feel that they're part of our, even though a lot of our team is based in Tokyo, we feel like they're part of our family, and it's been great to come out here and meet them all. So my presentation today is called Ruby Threads, and So Can You. The point of this presentation is I wanted to show just a practical way to implement multi-threading into your application. This doesn't use any kind of gems or any special magic. It's pure Ruby. And so let's get started. So we're going to start with an example problem that many of you have probably encountered. We're going to do a rake task which sends emails. In our case, our system sends daily reminder emails. Hey, your reservation is coming up tomorrow. And we send that to all customers who have an email or have a reservation tomorrow. So our task looks something like this, a very simple version, but we're going through the active record table and getting all the customers, and then we're calling some mailer class and sending the mail. Now, the problem with this is that the mail delivery API can be slow, and if we're sending hundreds of thousands of emails, this task will take a long time. So let's see how we can make it faster. So what I'm going to introduce is the producer-consumer pattern. The way that this works is we have a producer. In this case, it's the customer data. We're going to put each customer into a queue, and then we're going to have a consumer, which is the mail sender, handle that. So substituting for the actual class names, we have active record, customers each, and then customer, customer, customer in the queue, and then we're going to have consumers, which are pulling customers from the queue and sending an email to them. So to start with, and firstly, I made this presentation today, so pardon if there's things in the code that are quirky or not correct, but let's see. So the way we're going to start this off is we have this process method. The first thing I'm going to do is I'm going to assign a queue. And this queue, I'm going to use the size queue class. And what this class does is it's going to not let me add new things to the queue. On the thread, it's going to basically block the thread if the queue is full. And I have a producer, and I'll go through and show you how the producer is defined. But basically, the producer is done on a thread. It's going to insert things into the queue. And then I have the consumers, which is going to be n number of threads. In this case, I have 50 threads. I'm going to make 50 consumer threads. And I'm going to, at the end, join, which means wait for the thread to finish on each of those threads. And so the whole function won't complete until each consumer has done its job. So next slide. So the producer looks like this. Let me see. So basically, I'm going to iterate over the customer, all the customers. And this is the way Active Record works, actually, is it's going to be in SQL. It's kind of doing this as magic, but it's going to be using a get more command. So it's actually going to it's going to load the customers in batches. And so this is all, this is using a little bit of Rails magic here. But the nice thing is I don't necessarily have to load all customers at once. So if I have 1 million customers, I'm not going to fill up my process memory. I'm just going to get customers as I need them and insert to the queue. And because, remember, again, I'm using a size queue, it's going to prevent me from loading more customers until I've processed the customers in the queue. Now, one thing you might want to make sure is to set no timeout on your query, because if this runs for a long time, the database might kill your query, but that's another concern. At the end of this, I'm going to insert, for the number of threads I have, which in this case is 50, because I have 50 consumers, I'm going to insert this symbol, EOQ or end of queue, 50 times. And when my consumer sees this symbol, I'm going to then say that consumer is done. And so because I have 50 end of queue markers and 50 consumers, I'm going to see end of queue 50 times, and then one by one they're going to finish. and then the thread finishes, so my join is then once all of them have finished, the join will let the original method finish. Again, going back to this, and then it will be complete. Then my rake task complete, and I'm done. So that's that. So does this make a difference? Well, I just made some spoof classes here to kind of demonstrate what this would look like. But if we look at it, if I use a single thread, assuming I have 1,000 customers and 10 milliseconds per customer, it's going to take, in this example, it ended up being about 15 seconds in real time to complete with a single thread, and it was less than half a second with my producer-consumer pattern. So this will really speed up your tasks if you implement it. But wait, there's more. So let's talk about what we can do if we want to get fancy. We can actually have multiple queues, so I'm calling this a multi-stage pattern. Here's a real-world example. Suppose I have a bunch of files in an FTP. I want to download each of those files, and I want to upload them to Amazon S3, let's say. So in this case, downloading each file is going to take some time, and also uploading the file is going to take time as well. So what I can do is actually make multiple queues. I can have one producer inserting into my first queue, and then I can have these intermediate objects, producer-consumers, which are pulling from the first queue and putting them in the second queue, and then finally consume the second queue. So let's see what this looks like. Oh, actually, firstly, just substituting the names. So getting files from FTP. In this case, I'm just getting the file names to download. That's what's going to be in my first queue. I'm going to download each of those files, take the data, put it in the second queue, and then with the actual data, the byte data of the file, I'm going to upload that to S3. Okay, so in this example, I will have now two queues. They'll both be size queue, download queue and upload queue. For simplicity's sake, I'm just going to use the same number of threads for both my intermediate stage and my final stage. So like before, I have a download producer, and then I have an upload producer. That's my producer consumer. And then I have upload consumers finally. And so with this, I'm going to join on my producer consumer thread, which you're going to see, and then I'm also going to join on my end consumers thread, or threads, I should say. So for the download producer, this is really the same as before. I just have some method that's getting a list of file names and then inserting them into the download queue. So this is roughly the same as what we did with customers before. And of course, I'm adding the end of queue objects. Now, for my intermediate stage, this gets interesting. So I'm going to spawn a new thread, which is going to be for my upload producer. I only need one producer thread, but within that, I'm going to have n number of download consumer threads inside that. And then I'm going to join on each of the consumer threads inside my outer producer thread. And then finally, similar to the one before, I'm going to have an end of queue object that after these guys complete, then I'm going to put in, for the number of threads I have, the end of queue object. So this is, and that down there corresponds to the number of upload consumers I have. We're downloading first and then uploading. So the reason for the end of queue there, that's the end of queue objects for my second queue. And then finally, my consumers are really the same as before. So the way to think about this is starting with the simple example we had before with the customers and the email sending. It's really the first and last stage are the same. It's just I have this intermediate stage sandwiched in the middle. And you can really add as many stages as you want. So you can get fancy with this. I have more in my actual application. I have mutexes, which I'm using to track the count of each item. So I'm showing the the progress as I'm processing through each queue. There's a lot of fancy stuff you can do with it, but for the scope of this talk, I left that out. I'll put that up online on GitHub if anyone wants to check it out afterwards. So again, let's benchmark this. So in this case, I'm going to use a similar thing. I'm going to say 1,000 files, 10 milliseconds to download, 10 milliseconds to upload again. My single thread took 30 seconds, and again, my producer consumer took half a second. So this can really automate or really speed things up, and the differences really compound when you're doing things in multiple stages. So the last thing I'll say is, if you want to do this better, use Elixir. Elixir has abstractions which do this for you. So what I'm essentially showing you here is somewhat of a mock-up of what what Elixir does on a much more robust way, and we'll have microprocesses that are managing all this stuff for you. So I definitely recommend to check this out. Especially if you're doing a lot of this, Elixir may be a better tool for the job than Ruby. But hopefully you can apply this to your sprinkle this on your Ruby app too and get some performance benefit. And that's my presentation. So thank you everybody for listening. And by the way, our company's hiring. We do remote work, so if anyone's interested, check that out too as well. Thank you very much.
Thank you. Yeah, we might have a couple of questions. Is there any questions, guys, you'd like to ask? There we go.
Sure.
Yeah. What is the stack that you use at Table Check? What do you use for the front end?
We use React and Ember.js a bit. So we use React on the front end and Ember.js depending. We have actually a bunch of different applications. And on the back end, it's mostly a Ruby monolith. And then we have some Elixir microservices and data ingestion pipelines are all in Elixir. So Ruby and Elixir on the back end, React and Ember.js on the front end.
And how big is your team?
Our team, including Cybergeyser is about 15 people, and our entire engineering product QA is about 65 people now and growing, and our whole company is about 200 people today.
Okay, thank you. There is one more hand.
Thank you for the talk. I was wondering, how do you handle errors or retries after you have an error?
Great. Okay, so I actually extracted this code out of our actual application. I just went in and just started deleting stuff, and one of the things I deleted was the retry function. So what you want to do is do retrying within each consumer thread and within the producer thread. So if you think about it, right, suppose I have, in the case of the mail sending job, right, and I'm just going to be sending emails, suppose that one email has something in it that has an error. Well, I don't want that to stop all the other consumer threads from sending all their emails. So what I would do is if I go way back to this right here in the consumer thread, I would put a wrapper just around where it says my mailer with customer. I would put a retry wrapper in there, and I would make a retry function that takes the block and to kind of make the code clean. So I'll put that up on GitHub as well.
Okay. Any other? There we go.
Thanks. Yeah, great presentation. I have one question. How would you compare this kind of Ruby solution to solutions like async jobs, using active job and sidekick, stuff like that?
Sure. Well, basically, in that case, you're enqueuing stuff into a database, right? And that could be Redis in the case of Sidekick, or delayed job would use your SQL, or in our case, MongoDB. It's just more layers and more, more things can go wrong. I mean, this doesn't use a database, in theory. I mean, I guess you're getting your customer stuff from a database, but it doesn't use a database to process things fundamentally. So, Redis is actually very fast, but this is even faster because it's all happening within your process. You could actually combine the two. So for example, you could do something that is inserting, instead of where my mailer send, I could make that actually enqueue a job into Sidekick or delayed job, and then I could process that in a queue. So it's 6 or half a dozen, and it's really just your choice of, do you want something a little bit heavier but with more stateful management of each job in the queue, or do you just want to just crank through everything here? If you're looking for something quick and dirty, this is good.
Okay, so the last one, if there's any, could be the last one. Okay, so let's give some applause to Johnny. Thank you very much.
Thank you, everybody.